Good morning, or whatever your time zone is, because we have participants internationally. From wherever you are, welcome, and welcome to the second day of SESA, or the Space Education and Strategic Applications Conference. I'm Dr. Vernon Smith, Provost of the American Public University System, which includes American Military University and American Public University. Together with the Policy Studies Organization, we host this conference that has been already quite an event. If you were able to join yesterday, we kicked off the day with a keynote from Colonel Eileen Collins that highlighted leadership and the need to avoid flawed thinking. We concluded the day, if you were able to join, with a view of the stars with Dr. Ed Albin, the Department Chair of Space Studies at American Public University System, where he joined with the 24-inch telescope from Charlestown, West Virginia. From his home in Georgia, operating remotely, we were able to look at galaxies, and finally with a beautiful finale of seeing Jupiter and its moons. Just remind you to encourage you to sign up for on the conference app, WUVA, and also to remind that there are speaker profiles there. There are a way to follow the agenda and get information that's there. And I encourage you also to look at the profile of our speaker that I will introduce right now. Without further ado, we are honored and pleased to welcome world-renowned astronautical engineer, Robert Zubrin. His talk will examine many possibilities, starting with a discussion of the present-day breakthroughs. We will take a deeper look at where that leads to ultrafast global travel through suborbital space, to new industries in orbit, and to human settlement on the moon, Mars, the asteroids, the outer solar system, and ultimately the stars. All these things are possible, and he will explain how to achieve them. He will also look at things that we need to master and what that mastery implies, what we will gain by undertaking this grand adventure, and what we will lose by failing to do so. There is immense knowledge to be gained in space, but also deadly hazards to be faced, which we will need to control if we are to protect ourselves and all other life on Earth. The value of the challenge itself, both to stimulating the creative forces of society as a whole, and particularly of our youth, will also be explored. There's also a question of influence in an open frontier, or the lack thereof, of human freedom and the battle of ideas that can sustain it or defeat it, which many have discussed in the last day or so. Finally, there's a question of the human future itself. Will we be limited to one world with limited resources and limited prospects? Or will we become something grander in space, time, diversity, and ultimate potential? Please join me in welcoming pioneer astronautics president and world-renowned astronautical engineer, Robert Zubrin.
Thank you for that very kind introduction and very able summary of the subjects I hope to address. Although it's difficult to address all of that in a talk of an hour or less, but I have written a book on the subject, and after this talk, people think what I have to say is of interest. You can get this book, The Case for Space, on Amazon and read more. Okay, so the full title actually is The Case for Space, How the Revolution in Spaceflight Opens a Future of Unlimited Possibilities. So there's really three subjects there. There's the case, there's the revolution, and there's the unlimited possibilities. And I'll try to discuss them. First, let's start with the revolution. This is very visible going on right now. There's a revolution in spaceflight, and it has a number of components, which include the very prominently an entrepreneurial nature to it, the use of reusable space launch vehicles. There is also a revolution in spacecraft being driven by advances in electronics and related technologies. And there's also the beginning of development of technologies for turning materials in space into resources. But the thing that is very much in the news is the reusable launch vehicles and the entrepreneurs that are creating them. Now, of course, the cutting edge of this has been Spacex, Elon Musk's company, which has done incredible things, but it is not limited to them, as I will discuss. Okay, but let's start with Spacex. From 1970 to 2010, the cost of space launch was flat. It had gone down a lot between Sputnik in 1970 as we mastered the elements of the astronautical engineering art. But from 1970 through 2010, for the next 40 years, it was steady at $10,000 a kilogram. It's like a law of nature. But since 2010, as a result of SpaceX first introducing the Falcon 9 with lower costs due to entrepreneurial ways of doing business, and then much lower costs due to making it largely reusable, and then the reusable Falcon Heavy, even larger reusable vehicle, the cost of space launch has dropped by a factor of 5 over the past 10 years, from $10,000 a kilogram to $2,000 a kilogram. And as we speak, and of course is very visible in the news, SpaceX is pushing ahead to introduce a still more advanced vehicle, which they call Starship, which will both have double the capacity of the Falcon Heavy and be fully reusable. That it's a heavy lift vehicle with a payload capacity comparable to the Saturn V moon rocket, but which will have about 1% the cost because it's going to be fully reusable instead of expendable. And this promises to reduce the cost of space launch down from $2,000 a kilogram to several $100s a kilogram. So extraordinary reduction in costs going on. Now, this is going to have major effects. First of all, as the cost of space launch goes down, the number of space launches will increase. That's simple economic supply and demand. If an item is cheaper, more people can buy it. And they will. But also, the more space launches there are, the cheaper space launch becomes because of volume. And because, if you're running space launch operations, you basically have to pay the salary of the people who support the operations, whether they launch 4 rockets a year or 40 rockets a year. And, so this will help. Now, in addition, the spacecraft will become cheaper because, once again, volume production of the components that go into spacecraft, they'll be able to do these things cheaper. Now, furthermore, they'll become more capable. And they'll become more capable both because there's simply more spacecraft and therefore more chances for technological advance, but also, and this is very important, the engineers who design spacecraft will become less conservative. If it costs you $1 billion to launch a satellite, you're going to have a very low tolerance for risk for using technologies that haven't been used before. On the other hand, if it costs $1 million to launch a satellite, and you can use a technology that will cut the cost of the satellite from $100 million to $50 million, you might very well try that. You probably will. And so with engineers being less conservative and more space launches, the more advanced space technologies will be introduced and get a chance to be proven or disproven. And so whether these new spacecraft technologies make the spacecraft cheaper or lighter or increase the data rate or other capacities that the spacecraft has, propulsion, whatever, the spacecraft become more cost effective. So cheaper space launch allied with more cost effective spacecraft means that any business plan that is based on using these things, space technology or space launch, the numbers are going to start looking better and better. And so we're going to have more and more space industries, things like orbital research labs. NASA talked a little bit about this as the potential of the space station allied with the space shuttle. But that combination was incredibly expensive and restrictive. And so while there's a couple of demonstration projects that have been done, it really didn't take off. But if you cut the cost of space launch by 2 orders of magnitude compared to the shuttle, and now it becomes possible to launch private space stations where you don't have to go through all the bureaucracy of trying to get on the International Space Station, and you're not worried about the security of your information, you're going to do it. A lot of people are going to do it. We'll have dozens of these things. And then even in space manufacturing. So these are new markets that are going to open up. Now, there's an additional market that's going to open up, okay, I believe, which is intercontinental travel. Okay, last year there was about 100 space launches in the whole world, and about half of them are what you'd call the free world, and SpaceX got 60% of those, which is remarkable for one, frankly, not even terribly large aerospace company, much smaller than Boeing or Lockheed Martin, for example, to get 60% of the launch market as a result of its technology. Anyway, 100 launches in the world. Now that the space launches are going to be cheaper, it's pretty soon we're going to see 200 launches and then 300 launches. But there's several hundred intercontinental airplane flights every hour, okay? So if spacecraft can break into that market, then you're talking about 2 orders of magnitude further increase in the number of launches. And I think this is going to happen. For the past 3,000 years, people have made money on the Earth's ocean. And some have done it by actually trying to extract wealth from the ocean, for example, by fishing. But a much bigger business by far has been maritime transport, because in addition to being something that contains wealth, the ocean represents a low drag medium connecting every port city on the Earth to every other port city on the Earth. And it's been used for that purpose. Well, space is a zero drag medium connecting every point on Earth to every other point on Earth. It's a zero drag ocean surrounding everywhere on Earth. And traveling through it, you can get from anywhere to anywhere in less than an hour. Okay, you can go from Los Angeles to Sydney in less than an hour. I just came back from a flight to South Korea and from Denver, and it took 27 hours. And and there are people who will pay the extra amount to be able to do it in less than an hour, believe me. And so this is going to be a huge additional market, which will once again drive down the cost of space launch much more, and result in the production of large numbers of reusable launch vehicles. Now, I mentioned that SpaceX is leading this charge, but it's not the whole deal, and it isn't. Okay, people talk about Blue Origin and Virgin Galactic are in the game, but there's a different class of people altogether that are in the game. Rocket Lab was founded not by billionaires with loose change, but by working engineers who managed to get investors. This is a New Zealand company, and they have reached orbit. Now, New Zealand doesn't even have a space program, but New Zealand has reached orbit by an entrepreneurial initiative. And this opens this thing up to all sorts of countries that have not been major players in space. Having space be an entrepreneurial activity instead of a government activity means that you don't have to come from a country that has a major space program in order to start a major space initiative. And so this is going on as well, a multitude of additional players. Now, in addition, look, Musk is going to have very serious competition. I am aware of 5 companies in China that are led by engineers and which have investor backing, serious investor backing, which are basically all trying to create vehicles comparable to the Falcon 9, which is the current SpaceX vehicle that's dominating the world launch market. Now, Musk knows this, which is why he is working so hard on creating a launch vehicle that will make his current Falcons obsolete. Because by 2024, there's going to be Chinese vehicles that are comparable to the Falcon 9. And there's no stopping this, because once someone shows that something is possible, the laws of engineering are the same for everyone, and engineers elsewhere will be able to find financiers that will give them the backing to do what the financiers now know is possible, and they'll do it. And of course, and I know this is an audience that includes people with a major concern for national defense, the ability to do cheap space launch and repeated space launch on rapid rates is fundamental to national defense. I actually view space capabilities right now as the decisive capabilities in warfare. Because if you think about, okay, nuclear weapons, of course, the most powerful weapons, but if you're fighting against a nuclear power, neither side is going to use them because the retaliation would be too consequential. And so now you're looking at conventional war. Now, United States in its wars since Vietnam anyway, has made use of reconnaissance satellites, and especially in the more recent ones with Iraq, GPS and so forth. And these have all become better and quite useful. But it hasn't been apparent that these have been decisive importance, because frankly, we would have beaten Saddam Hussein whether or not we had GPS-guided munitions or reconnaissance satellites. But if we were actually in a conflict with a peer adversary, these would be decisive. I mean, imagine if World War II, if in World War II, the Axis had just one of our current space assets, reconnaissance satellites, and we did not, then, well, clearly the Japanese would have won the Battle of Midway. They would have seen our carriers long before we had spotted them. They would have launched a strike. They would have sunk our fleet. The U-boats would have won the Battle of the Atlantic. The Soviets never could have put together armored counterattacks at Stalingrad or elsewhere. They would have been spotted long before they could do anything, and they would have been taken out from the air. And in other words, the Axis, even though it was greatly inferior in military industrial capability, would have actually won World War II. Japan would have defeated the United States if they had had space assets, and we did not. So this is of decisive importance. So it's a very important thing that we do everything we can to help foster this entrepreneurial development. But now let's move on a little bit here. Okay, I've talked about intercontinental transport. I've talked about orbital industrial capabilities and all these things. What about other planets? Well, look, I mean, we could, without this stuff, I mean, if NASA had its act together as well as it did in the 1960s, we could have sent people to Mars long ago. We did not need this stuff. What we really needed was the kind of leadership we had in the 60s, both in NASA and in the political class. And we could have sent humans to Mars by the 1980s, and certainly in any 10-year period starting now. But if you're talking about not just sending human explorers to Mars, but settling Mars, then you have to greatly reduce the cost of transport. And this is what this will allow us to do. And also, if you think about a world in which there are thousands of starships engaged in intercontinental travel, the idea of buying used ones and using them to send people to Mars, the whole proposition becomes much cheaper. And in fact, immigrants would be able to buy their starships and keep them with them on Mars as starter housing. Now, and this brings us to another thing that I mentioned, which is the use of space resources. Now, actually, space resources do not exist. Space materials exist. There's no such thing as a natural resource on any planet, including the Earth. It is human ingenuity, human technology that turns materials into resources. Okay. The only reason why land is currently a resource on Earth is because people invented agriculture. Before that, it was not a resource. And the value of land as a resource has multiplied as our expertise in agriculture has developed over the centuries. In the Bronze Age, iron was not a resource. People didn't know how to smelt it. It was just, red colored rocks. And they spent a great deal of effort producing bronze, far more expensive material than iron, which then became available once the technology to create iron metal out of rock was invented. And then aluminum did not become a resource until the 20th century. Until then, it was just dirt. Okay, go into any Old West antique store, any genuine antique store, you won't find any items made of aluminum because it did not exist until the late 19th century. And and so forth. Well, Mars has got all sorts of materials, which could be extremely useful once we develop the technologies for turning them into resources. Now, some of these are pretty obvious. There's carbon dioxide and water ice on Mars, and with relatively simple technology, we can turn that into methane and oxygen rocket propellant. And this, I believe, is actually the key to an effective, cost-effective Mars mission. This is what I outlined back in 1990 in my Mars Direct plan, and which has since been embraced by SpaceX. The reason why Starship uses methane oxygen propellant is so that it can make its return propellant on Mars. But there's Mars is red because it's iron oxide rich, and you can reduce that iron oxide and produce steel as well as more oxygen, and so forth. And developing these technologies is the key. An environment is habitable for you when you can turn the things there into resources. Somebody stranded on a desert island, if he knows how to make use, how to open the coconuts, then he's got food to eat. If he doesn't, then he has none. And so the coconuts are either a resource or they're not, depending upon his skill. And the same with fishing and what have you. And so if we develop these technologies, then these places become settleable. Now, the entrepreneurial space revolution has had repercussions outside of the space field in a number of areas, and I'll discuss one, which is a very important one, which is fusion power. Fusion power actually progressed fairly steadily from the 50s through the 80s due to international competition between the government-led American, Soviet, European, and Japanese space fusion programs. But since the 80s, they have stagnated because the bureaucrats from these different programs got together and they decided all this competition was very annoying and stressful, and why don't we work together on one program? And that brought things to a screeching halt. So there hasn't been much progress in fusion in the government programs since the 1980s. They collapsed all the national programs into this international program called ITER, and they spent the next 25 years discussing where to put it and so forth. But as a result of the success of SpaceX, investors have taken a look at this and said, well, maybe the problem with fusion isn't fundamentally the technical issue. Maybe the problem was the same as that with reusable space launch, which is institutional. And now there are entrepreneurial fusion companies. And for instance, Tri-Alpha Energy in California has gotten $800 million in investment, which is larger than the US government fusion program. And there's a multitude of others. I discuss some of them in my book, including internationally, the very energetic British fusion program called Tokamak Energy, which is actually working on a fusion concept called a spherical tokamak, which I actually did a little work on in the 1980s at Los Alamos, but it was considered too avant-garde for be considered for ITER. Well, Tokamak Energy is doing it, and there's several others. So and these people are not working on 30-year timelines. Investors are not interested in 30-year timelines. They're working on 5-year timelines to bring about fusion ignition systems. Now, fusion, of course, is a great source of energy for the Earth, and that's the market they are going for. But it's also a great source of energy for Mars, by the way. The Mars deuterium, which is the fuel for fusion reactors, is 5 times as common as it is on Earth. But also, It's not just another way to light light bulbs. It's a new kind of energy, just like nuclear energy is just another way to light light bulbs on land, but at sea, it enables nuclear submarines, which is a qualitatively superior kind of submarine that you can do with nuclear energy and you can't do with coal or solar energy or something like that. Well, fusion energy, in addition to being able to power submarines, will be able to power spacecraft. And in fact, to take spacecraft up to 10% the speed of the light. So you're talking about a marginal capability for interstellar travel. Okay, and this is what, power that lights the stars is going to take us to the stars. What is coming out of this. But once again, the thing that's ultimately driving it is human creativity, liberty, the entrepreneurial space revolution. Now, let's shift gears a little bit here to talk about why this is fundamentally necessary. And as Vernon alluded to in his introduction, there's a number of reasons that I see. And these can be categorized as, for the knowledge, for our survival, for the challenge, and for the future. Now, the knowledge, this is one that NASA actually does talk about, of course. They talk about the scientific discoveries they're making. And this is certainly a valid reason to support the space program. But let's expand this a little bit here. Let's talk about two important fields of knowledge, astronomy and biology. Astronomy has frequently led physics. Many of our fundamental discoveries in physics have actually come from astronomy. Classical physics, the law of gravity, the classical laws of motion, Newton's laws came from astronomy. Much of electromagnetism came from astronomy. Relativity came from astronomy. Nuclear fusion was discovered through astronomy. It's the power that drives the sun. It wasn't discovered on Earth. It was discovered in the sun. Okay, and there are laws of physics waiting to be discovered in space. And there is no better place to do space than do astronomy than space, because you're above the thick atmosphere and you've got a clear view. And with this spaceflight revolution, we're going to be able to launch a lot of space telescopes and construct much bigger space telescopes. And we're going to make fundamental discoveries about the laws of nature that will greatly enhance human capabilities. Now, biology, we don't really know anything about biology right now. We know about one kind of biology, which is Earth biology. And Earth biology is all the same. All organisms on Earth, whether you're talking about bacteria, mushrooms, crocodiles, or people, all use the same genetic code. They all use the same amino acids, the same alphabet for transmitting genetic information, DNA and RNA. Now, there's a priori reasons why you could argue that life should make use of the unique chemical properties of water and carbon to create biological molecules, but DNA and RNA is a very specific alphabet. Now, okay, we are Americans, we use the Latin alphabet because the Roman Empire expanded to include England and left us with their alphabet. And places where the Roman Church went, like Poland, also used the Latin alphabet. But there are other alphabets. If all you knew was America and Western Europe, you'd think the Latin alphabet was the alphabet. But you go a little further east, you go to Russia, there's a different alphabet. Now it has a fair amount in common with our alphabet. Some of the letters are the same, and certainly the system of sounding out words using letters is the same. But if you go further away, then China, there is an alphabet. Well, we'll put it this way, it's not exactly an alphabet. It's a system for recording information, and it serves the same function as an alphabet. You can write books in it, but it is not based on sounding out words. It's based on pictograms and that have been simplified. So it's a completely different information system altogether, yet it works. Okay, now we've had different information systems in our computers. So the first one worked on gears and levers, then we had vacuum tubes and electromechanical relays, and then silicon, and now people are working on quantum computers and DNA computers and things, and which will be potentially much more advanced than silicon. And So if we can discover new biological information systems, for example, by going to Mars, which may well have evolved life in its early history and may still harbor it in underground water, you're going to make fundamental discoveries about what is possible with life. Now, life, okay, in particular microbial life, is self-replicating machines. And we have recently learned how to read the programs in these machines, the genetic codes, and we're beginning to learn how to write them and create organisms that will do specified tasks, programmable, self-replicating machines. Well, this is a technology of enormous power, and we're going to be able to discover some of its possible potentials by going to Mars and elsewhere in space, where places which have a separate origin of life than Earth. Now, the challenge, okay, I was growing up in the 60s during Apollo, and that's why I got a scientific education. I wanted to be part of the great adventure of human expansion to space. And I was not alone. The number of science and engineering graduates in this country doubled, and in some fields tripled during the 60s as a result of the Apollo program. And you can see that very clearly, because as soon as the program stops in early 70s, we go from exponential increase in science graduates to completely flat number of graduates. In fact, slight decline relative to the population, and a significant decline relative to the college educated population. A Humans to Mars program, a bold space program today, could have an even larger effect because, for instance, the scientific and engineering professions are much more open to women than they were today than in the 1960s in real terms. So that not only would a Humans to Mars program produce the phenomenon of millions of little boy mad scientists making rocket fuel and robots in the basement, you'd have little girl mad scientists too, which is kind of a scary thought, but there it is. And, I'm a little bit exceptional in my generation in that I actually went into doing space stuff. Most of the rest of them went off and they built Silicon Valley in the 1990s, and that's why they're a lot richer than me. But the point is, society benefited enormously from this creation of intellectual potential. And the way you do that, youth loves adventure. Make science the great adventure, and space is what does that. Certainly not increased standardized testing, that does not do it. Then there is survival. Let me just check the time. Okay, we're still good. A lot of people don't understand where the Earth is. Okay, so I'll tell you. The Earth is in space. That's where the Earth is. Okay, the Earth is in outer space. You're living in outer space. Okay, that's where you're living. And you and everybody else in outer space and everything else in outer space is moving around under Newton's laws, which sends them to very high velocities as they orbit the sun, and on irregular trajectories, which therefore cause them to crash into each other periodically. And when they do, the smaller objects are totally destroyed, and the larger objects receive quite a punch. And when this happens, of course, we can have mass extinctions on Earth. Now, everybody knows about the dinosaurs like 65 million years ago, and maybe you visited Meteor Crater in Arizona, that was 50,000 years ago. But, Tunguska in Siberia was only 100 years ago. And there was another impact in Siberia in 1948 that actually killed a lot of wildlife and trees and what have you. And in fact, we had an impact in 2018 over the Bering Sea. That didn't kill anybody. It exploded at 60,000 feet with an energy equal to 10 times the Hiroshima bomb. Okay, so this stuff is happening, and it's going to happen. And we have to get control of this flight traffic, or we're not going to be safe. I knew Sagan used to say all species either become spacefaring or extinct, and that's the truth. And I do not agree with people who talk about this and say, well, we got to go into space so that when the asteroid destroys the Earth, there'll be survivors somewhere else. I think that's a ridiculous way to look at the problem. Okay, we're not going into space to desert the Earth. We're going into space to protect the Earth. And by becoming spacefarers, we could become capable of identifying hazards and diverting them so that there are no such impacts. And that's what we need to do. And then finally, I want to talk about the future, and not just the far future. Okay, well, let's talk about the far future. Okay, and then we'll talk about the near future. The far future is, what's the human race going to look like 500 years from now or 1,000 years from now? Well, I think that if we do what we can do in our time, what the human race is going to look like 500 years from now is thousands of civilizations that do not yet exist, existing on thousands of planets orbiting stars in this region of the galaxy. And we're talking about new nations, new cultures, new political systems, new literatures, enormous diversity of contributions to technology and invention, and histories of great deeds of great people that will be used to inspire those who will go further. And that is something grand and magnificent. And if you have it in your power to create something grand and magnificent, then you should. Okay, but well, that's one view of how this relates to the future, and it's an important one. But I want to get a little bit more closer to home here, because how you view the far future greatly affects how you're going to deal with the near future. Okay, because there's an alternative vision of the near future, which is one of resource exhaustion and nations fighting each other over ever more scarce resources. And that leads in a certain direction. Because, I mean, look, what is the major threat to humanity today? If you ask that of global thinkers, most of them will say fashionable answers like it's climate change, or some will say resource exhaustion, or even it was very popular a few years ago to talk about overpopulation. But in fact, while climate change is real, it's not an existential threat to humanity. And resource exhaustion is not real, and overpopulation is not real. And certainly, whether you agree with those points or not, what you have to admit is that none of those things were the cause of the great disasters of the 20th century. The great disaster of the 20th century was not caused by climate change, certainly. It was not caused by resource exhaustion, and it wasn't caused by overpopulation. Okay, the world had, in the time of World War II, 2 billion people. It was caused by something else. It was caused by bad ideas. And in particular, one bad idea that came in a variety of forms. And what that bad idea is that there isn't enough for everybody. Because there isn't enough for everybody, we have to take what's here from them so that we get it instead of them. And this is what caused the World War I, World War II, the Holocaust, the Holodomor, and all sorts of other things that one could name. 1912, General Friedrich von Bernhardi, chief intellectual of German general staff, wrote a book, international bestseller in English. It's called Germany in the Next War, in which he said, look, there's only so much here, and who's going to get Eurasia? It's either going to be us Germans or the Russians. So we're going to have to take them down. We're going to have to fight them sooner or later. Should it be sooner or should it be later? Well, clearly sooner, because we can destroy them now before they've industrialized, whereas later on, they'll be stronger than us. So let's go. And therefore, 2 years later, they took advantage of the crisis precipitated by the assassination of the Austrian Archduke to launch World War I to try to settle the matter. And same thing with Japan in China in the 1930s. Who's going to get Asia, us or them? Well, we're going to have to fight them sooner or later. Now's the time while they're weak. Okay. And in fact, it always will be to the advantage of one power or another. If you're going to have to fight sooner or later, it will be the advantage of one or the other to make it sooner. Okay. So 1914, despite the fact that Europe was doing better than it ever had been done in human history, just turned on itself and destroyed itself. Not because of any objective factors. They were doing better than they ever had been. and they destroyed each other. And then 1939, Hitler, even more hysterically, the laws of existence require uninterrupted killing so that the better may live. Germany needs living space. This is all absolute nonsense. There's no truth in this whatsoever. Germany did not need living space. Germany today has less space considerably than the Third Reich, and a larger population, but a much higher standard of living. Why? They did not achieve that by successfully invading other countries and killing the people there so they could steal their cows. Okay, they were ultimately unsuccessful in that project. And it didn't raise their standard of living at all while it was temporarily successful. The thing that raised Germany's living standards was the advance of science and technology, which has been a global project participated in by all nations, including, of course, Germans, but also many people from groups that they were trying to exterminate. And that's why they're richer, because it is not true that nations are in a struggle for existence over limited resources. Nations are a disorderly family, parts of humanity that are engaged in a joint project to expand the amount of resources available to humanity by creating new technologies. And, look, I happen to know, because I have talked to them, that there are people in significant positions in the American national security establishment who believe that war with China is inevitable. Why? Because, there's only so much oil in the world, and if the Chinese, is 1.3 billion Chinese, and they all have a standard of living like ours, or even Europe, so that most of them have cars, there won't be enough oil for us and them. And then you could bet your bottom dollar that there are comparable people in Beijing who look at this issue from the opposite side of the chessboard and think comparable thoughts, except with a different side that they would prefer to wipe out. Now, and if this kind of thinking is allowed to prevail, there will be war, and it will be far more catastrophic than the last two world wars because our weaponry is far more effective. And but it's nonsense. Look, why is China progressing so fast right now and for the past 30 years? Because of technologies like electricity and electronic devices, these things that were invented in the West. But we had our own renaissance in the first place because of technologies like paper and printing that were developed in the East. And so we are actually in this joint project. And that is why, by the way, as the world's standard of living has gone up, as the world's population has gone up, the standard of living has gone up, because the more people there are, it's not that there's more mouth to feed, it's that there's more minds to invent. The more people, the more inventors, the more inventors, the more inventions, and inventions are cumulative, and inventions made anywhere ultimately become used everywhere. Okay, but people don't see this. They say there's only so much to go around. Sooner or later, we're going to have to fight it out with them. And at that point, you're in a pre-war situation, and you are dooming yourself. Okay, but it's all nonsense. We are not in danger of there being too many people. We're in danger from people who think there are too many people. Okay, and they have to be refuted. And the problem is it seems intuitive that if you're just on one planet, that there's only so much here, but it's not true. Okay, just as it's not true that there are only so many points in a line segment. There's actually an infinite number of points in a line segment, but intuition says there could only be a finite number of points in a finite line segment. However, if you make it clear that you're not limited to a line segment, if you have an infinite line going off in unlimited directions, then it's clear to even someone uneducated in mathematics that there's an infinite number of points available. And so the point I'm making here is that we're not going to get oil from Mars. We may get inventions from Mars. The Martians may be the ones that actually make fusion power practical because they got deuterium and they don't have waterfalls in fossil fuels. But really what we're going to get from Mars is wisdom. We're going to get the knowledge that it's not true that there's only so much here, because the Earth comes with an infinite sky. And if we work together, we can throw it wide open. And that's the case for space. I've got sunlight coming through my window here. I'm going to just close this. Yeah. Better. All right. Somewhat better. All right. I would be delighted to take questions.
Fantastic, Dr. Rubin. We have one from Trace Holton, who says, Dr. Zubrin, does inspiration 4 demonstrate mankind still possesses, as you eloquently describe in your books, moxie, as well as the precedent for an all-civilian Mars direct mission?
Well, it certainly helps. I mean, look, NASA in selecting their astronauts went and selected, people who has physical specimens are in the top 0.1%, and they put them through, half a decade of training before they let them fly. And, they had to have been test pilots before they could go in a space capsule and shot down at least 12 MiGs and whatever. And here's inspiration 4. These people were selected a few months ago, and one of them is actually a person who is physically disabled, and the rest, I think one has a background as a pilot, but basically said, they can do it with a few months training and they can go, okay? And furthermore, the rocket that launched them, was a factor of 5 cheaper than a comparable rocket 10 years ago, which is why, a rather wealthy entrepreneur paid for this, $60 million for a Falcon 9 launch, but he wouldn't have been able to pay for it if it was $200 million. And this stuff's going to get cheaper. And, but, what we're seeing is that if not everyone, at least average people in the upper, 70%, that is from the 30th percentile on up of physical condition, can do space flight. And furthermore, it's being made cheap enough to do. And also, I think, Musk in Boca Chica there, he's not building a ship, he's building a shipyard. They're turning out Starship prototypes at a rate of 1 a month, okay? And that's why he's able to follow this very energetic development program, build them, fly them, crash them, figure out what went wrong, launch the next one the next month, keep going. Now, and he intends, by the way, to create a fleet of Starships, of hundreds of them, to do missions. And if there's hundreds of them, they're going to be cheap enough to send to Mars one way, as I said, because colonization is a one-way trip. One of the difficulties of using Starships as an exploration vehicle is they're rather big and take a lot of fuel to send one back. But maybe you send one back for every 10 you send to Mars, because if you're colonizing, only a few people are coming back. There aren't that many people on Mars that want to come to Earth. And the so yeah, this is certainly a step in showing that this is possible.
Thank you for that. Another question from Dr. Arnold Nikogosian, who asks, do we need more space stations in low Earth orbit? Well,
humanity needs more space stations in low Earth orbit. In other words, it's not that NASA needs more space stations. NASA has a space station, and it has performed a useful function in showing, well, this is one way you can build a space station. Space stations are possible. Here's one. But I think what we're going to see are private space stations. Space stations launched initially, a company like Pfizer or major pharmaceutical company with annual incomes in tens of billions of dollars will certainly be able to launch their own space station research facility and use it as they choose to develop drugs and such in zero G. The questioner, I think, was a major factor in creation of NASA's space station and was looking for it as a place to do biological research. But the infrequency of shuttle launch, the cost of shuttle launch, the difficulties of negotiating the regulations of the space station, the need to protect intellectual property from competitors, all made this not very attractive. But nevertheless, using private space launch, where $100 million investment to create your own space station is well within the range of Fortune 500 companies, and they'll do it, and they'll have their orbital research facilities.
Something to definitely look forward to in the future. Another question comes in. Dr. Zubrin, thanks for commenting on actual scarcity versus mentality. How do you think the infrastructure bill will help support America's new space race?
Well, actually, I haven't read the infrastructure bill. I don't know anyone who has. I'm not sure I believe that there is anyone who has. But certainly having government funding, was important for SpaceX. Okay, SpaceX was built by, yes, private investment to create very novel launch vehicles, but they were turned profitable by government contracts to launch NASA and military satellites. And without that, it would not have succeeded. Now, so by being a customer for space launch, they can help this happen. But let me be specific here. It's important that NASA and the military be an intelligent customer. Okay, the free market requires free competition of sellers, and it also requires buyers who are free to choose on the basis of merit. Okay, some of NASA's procurements, there's political direction or attempted political direction to force a given space exploration probe to use a certain launcher, which is not in the interest of the mission. Now, if that is happening, if you have political command as to which launcher is going to be used, that is detrimental to the advance of the industry itself. Okay, in other words, the Test Space Telescope was launched on a Falcon 9 at a launch cost of $65 million instead of on a Delta for $200 million. And that allowed the Science Directorate to save $150 million they can use to develop other things, other telescopes or planetary probes or something. And that's a good thing. There was an attempt by some to make the Eureka Clipper have to launch on the SLS, which A, is very expensive, and B, doesn't exist, and C, when it does exist, will only launch once per year. And but now they were liberated from that. Having NASA and the military be allowed to be intelligent customers, because if you have the mission directorates in these institutions, the guys who are doing the mission, okay, they're always going to want to choose the most cost-effective launcher. But if they have, as it were, higher direction, well, we want you to use this launcher, okay, then they no longer become a driver for merit.
It makes sense. Here's a real engineering question for you. Do pulsed electromagnetic fields have the potential to protect planets and humans in a HAB setting on the surface of Mars? I know this means open discussion to the radiation exposure. Does it really matter? It's a little bit jumbled, but I hope that the question makes sense.
All right. Well, I don't think we can create planetary magnetic field, at least not within the next century. We have the capability of creating planetary magnetic fields. I have to say, though, the Earth's magnetic field does provide protection against solar flares to space stations and such in low Earth orbit, but we on the ground are actually protected much more by the atmosphere. In other words, the Earth's atmosphere, it's like you're under 10 meters of water. That's how much mass is sitting above you. shielding you not only against solar flares, but against much more energetic cosmic rays, which, by the way, do reach low Earth orbit. In fact, the cosmic ray dose on the International Space Station is half of what you would get if you're in interplanetary space on your way to Mars. And the only reason why it's half is because you got the Earth under you blocking out half the sky. The magnetic field is too weak to block gigavolt class cosmic rays. It does block megavolt class protons from the sun. But the way we're going to be shielded on Mars is, first of all, the Martian atmosphere, as thin as it is thick enough to block out most of solar flares, but of course not cosmic rays. I think that the majority of living space in a Mars habitat will be underground or under ice or underwater. Mars Society recently had a contest to design Mars cities and Mars habitats and such. And some people came up with an interesting idea of having liquid water aquariums above the habitat, in which your fish farms are up there. You look up and you see the fish, and they're also blocking out the space radiation. Although agricultural domes will have to be on the surface to get sunlight. But even so, I mean, the cosmic radiation is not going to endanger agriculture, plants, and so forth. And if you can cut it down by, well, first of all, on Mars, you're cutting it down by a factor 2 by having Mars under you. And if you can cut it down by a further factor of 3 by only spending 8 hours a day outside upstairs, and how much of your time on Earth do you actually spend outside? So you'd cut the radiation dose down to something quite manageable.
Wonderful. We are at time. Dr. Zubrin, this has been a fantastic. I'm glad you have your book displayed right there for our participants to be able to pick up and look at that. Any final words that you would like us, for me, one of my takeaways is your statement: we are not in danger of too many people. We're in danger of people who think there are too many people, will be one of my absolute takeaways from this, and very eloquently stated. Is there anything else that you would like to share as a final note in your remarks this morning?
Well, sure. Well, two things. Well, first of all, just as a commercial, I lead a nonprofit called the Mars Society. We're at marssociety.org. And we're having our international conference. There's going to be a virtual conference on Zoom, October 14th through 18th. Anyone who wants to can register and attend all the talks. And the agenda is going to be posted within about a week. And there'll be a lot of very interesting talks about various aspects of Mars exploration and settlement. But in terms of final remark to this, it once again goes to this question of how you conceive the relationship between humans and resources. Are humans consumers of resources or creators of resources? Now, I say we are creators of resources, and the proof of that is there's a lot more resources on Earth now than there was before people came along, and that the average person must contribute more to creating things than destroying things, or if that was not true over the long term, there'd be nothing here. Okay, but think about it this way. Okay, if you accept the idea that humans are consumers, that we are vermin upon the earth, consuming what is here, then fundamentally every person is the enemy of every other person. Every nation is the enemy of every other nation. Every new child born is a threat to all of us. And the fundamental function of government must be to limit human numbers, activities, and liberties. But if, on the other hand, you view humans as creators, then every other person is potentially and fundamentally a friend of every other person, every nation a friend of every other nation, and every newborn birth is a gift. And the fundamental function of government must be to protect human liberty at all costs. So it is this question of winning this intellectual battle. The battle for the human future is fundamentally an intellectual battle. of whether we can create a golden age or whether we'll destroy each other. Because one belief will lead to destruction, and the other could lead to the greatest age of human progress we've ever seen.
Thank you so much. On behalf of the Policy Studies Organization and American Public University System, we can't thank you enough. We look forward to promoting the Mars Society meeting on October 14th through 18th. And we hope to be able to see and work with you in the future. And thank you for joining us this morning, Dr. Zubrin.
Okay, it's been a pleasure. Thank you very much for inviting me.